All right, so welcome back to part 2. This is lesson 7. We're going to continue down the Numpy path. So our objective here for everything is to take a deeper dive into the Numpy package and see how we can use it. So aggregations is the first topic we're going to talk about. And these provide operations that a lot of us are probably familiar with. That includes sum, mean, max, min, standard deviation. And they provide us a look. You can look at the array and get basic information out of it and statistics. So what we're going to do here is we're going to import numpy as np, create a random int, print it out, look at the minimum and maximum values, sum them up, get the average value and the standard deviation. So here we have the minimum value for array is 80, maximum value is 92, which is here. The sum of all the values is 332, the average is 16.6, and the standard deviation is 40.41. So now we have some basic understanding. So we can do our row and column aggregations, but it all depends on the variable called axis. So for axis 0 in NumPy, that means columns. And for axis 1, that means doing everything on the row based. And we can see the difference here. We're going to create another new random integer called b, matrix. And we can see that we get our column summations and our row summations. And it aligns to exactly how the graphic shows up above. So like integer or string comparisons, we can use we can compare single value or other arrays as well. So we can go ahead and use the greater than, less than, not equal to symbols. All those things you're used to when doing if statements. And although that's in the standard library, you can do it on NumPy arrays. So let's go ahead and create another two NumPy arrays, A and B, and then we can do a comparison between the two. Is A greater than B for C, and we can see we get back for each value is compared to each other. So we have 0 to -1, 1 to 0.5. So we can see that A is greater than -1, 1 is greater than 0.5, but 2 is not greater than 2. And then we can do some other comparison checks, like checking if making sure that all the Boolean logic came back as true, or that there was at least some truths in it. So that's what any will do for us. So we had one false in our resulting array C. So for all, you'll get back false, and then for any, you'll get back true because there was at least one. Because Boolean values map to integer values, where true is 1 and false is 0, we can do calculations on them, like counting the number of truths or figuring out the number of false statements. So here we're going to count the number of truths by just summing up that previous example of C, and we should get 2, and then we can figure out the number of false values, which is just take the total size minus the sum of all true, and that should give us the answer. That's one way of doing it. So let's load some real world data and look at some values in there. And what we're going to do is I'm going to use pandas to go in, and I'm going to read some information, get a single column values, and convert it to a NumPy array. The reason I'm using pandas instead of NumPy to do this is because pandas makes it really easy to pull down data and be able to start working with it. So, and it has a really nice property value that can convert it to array. So I have my data called temps, which is the temperature for this area from 2017. We can go ahead and we can do some analysis on it. We can look at the number of days temperature below 0, and then we can also compare more than one condition. So here's an example of summing up the number of days where temp is greater than 0 and it's less than 10, and we can get those total numbers. So we can see for that whole year in 2017 for this area there were 49 days with the values were below 0, and for our condition there was 185 days. We can sort data. There's two general ways of doing this. So there's np sort, which will take your array, make a copy of your array in memory. So now you have two copies of your data and put it in the sorted value, whether you're sorting by array or column. And then you can, on the actual array itself, you can do dot sort, and you can perform that action. So here we have our random data set, and we're going to bring in some data. So we're going to sort by our columns, so vertically, and we get our data in sorted order. it just so happened our first column was pretty much sorted. We just had to flip the 6 and the 8, but you can see it more on the second column. Everything's being applied. Then we can do the same thing, and we can sort by the row, which is the default, and we can see that we get our information sorted when we compare from the original. Another way to sort is that we can use this arg sort, and arg sort is going to allow us to get back our sorted index. So we know that the order for our data in the sorted order is 0, 1, 2, 3, or 3, 0, 1, 2 for the original values of our random array. We're going to do some examples now using the iris data set. So just remember that it's 50 samples, 3 species of iris for 150 total samples with the various column values here. And so we can pull it in. We're just going to use the scikit-learn package, and we're going to be able to, and it has the various column names. We can take this information and we can see relationships between the two data sets, or two columns. And what we're going to do is we're going to show the relationship between two columns, which is the, I believe we're comparing lengths, and see if they correlate. And we're going to, but the assumption is just that our data set is normally distributed. And we can check that as well, but in this example, I'm not going to do that. And we can see that there's a high relationship between column 0 and column 2. And we can see that there's also the correlation matrix. And we would assume that everything on the diagonal is comparing it to itself. So that should always be 1. And then this is actually comparing the values. And the top half of the matrix is the same as the bottom half. So you really only have to look at either above the diagonal or below the diagonal, because it shows the same information. So now getting to more things that we can do with raster analysis and other information, we can use Numpy to process imagery. And because an image is just a collection of pixels, generally they're squares, and they represent numbers between 0 and 255. And each, so think of each spot in your matrix as an XY coordinate pair, and the values, if they're floats, are between 0 and 1, and for integers are between 0 and 255. So let's go take a look. I have an image here called painting. We're just going to take a look to see what it looks like. So we see the size here. I printed that out. It gives us the shape and the total number of pixels that we have. And here's our image. It's just the image of a painting. So we can go ahead and we can do some information like this. So we're going to look at the painting again, and we're going to remap some pixels. I'm going to make a copy of my data set, and I'm just going to sort of chop off the first 30 rows and set it. So here we can see that we have now white space above where the original painting was. We can then go ahead and do additional manipulation. Here I'm going to adjust the colors. So to do shading, I want my picture to be darker. I want to give it this dark feel. So maybe it's dusk now in this image. So I took an original picture. If we go back one slide, we can see that it was a lot brighter. But when we come back to here, we can see that we've made it a lot darker by just doing some simple calculations from matrix to matrix. So we can also convert it to grayscale. Here we're just putting in some weights to convert it on our image, and then setting our color map to gray for matplotlib. Because if we don't set it for matplotlib, it will just choose a random color scale based on whatever the numbers are and try to align it up. Other examples is, let's say we have images and we want to detect points within the images or certain types of pixels. So I'm going to create a random data set, and what I have here is I have the background is just set to purple, and notice that there's some dots in there, these random points, and they're set to the value of 1. And we want to go ahead and we want to detect this. So we can use filtering from scikit-image, so nd image, and then this Gaussian filter. I'm sorry, this is going to create like this blurring effect. Now we can go ahead and find the number of clusters. So we're going to use nd image, and we're going to do some simple calculations to create a mask. And this is we're gonna take our array and find all values that are greater than the mean, the average pixel value, and that should give us our point locations. And then we can go ahead and we can connect them to it, and then we can find the number of clusters and then show it in the map. So here what we did is for all the previous clusters that we had here on the picture that we originally created that's greater than our mean, so like the things that the anomalies are sort of standing out, we've been able to extract them and put them back on our image and label them properly and show that the greater the intensity, they stand out more. So these are just some of the very basic things we can do with NumPy arrays, and we can apply it to both raster data and even tabular data, and you can do very powerful analysis with it. So if you have any questions, please post it to the forums. I hope you found this informative, and have a good day.